Right, guys. Now let us continue our discussion on certain methods on set objects. So, set, as we all know, is simply a collection of items, with the constraint being that if we try to add duplicate elements, then that duplicacy is removed and there is no order that is defined as such. So, first of all, is to add a particular item, that is adding a single item to the list. We can also update. We can update to add multiple items to the set. We can also update to add items from all the provided sets to the set. Like, say we are using an API and we are getting set from the fetched API results, then we can update it with the set as well. We can also remove a single item from the set using the remove method. And similar to list, we can use pop and we can remove and return a random item from the set. See why it is random? Because the order is not defined. And similar to set operations, which you might have studied in mathematics, we can take the difference of a couple of sets to return items in the set that are not in another set. Or we can return intersection to return items that are present in both the sets. So if I were to draw a couple of circles and whatever is their intersection area, that is how the intersection of a couple of sets is defined. Union, on the other hand, is to return items that are present in either of the two sets. Or basically, again, if two circles are intersecting, their entire portion of area without the repeated intersecting portion. Symmetric difference of a couple of sets to return items that are only in one set but not in both. That is, we subtract the uh, intersecting area in order to get the symmetric difference. Then we can find out whether a set is superset of another set or not. So a set is said to be a superset if all the elements that are present in the child set are also present in the parent set. Then the parent set would be called a superset. We'll see all these examples in action as well. And is subset, again, if a portion of those elements are contained in the child set, then the child set is called a subset of that container. Is the set contained in another set, right? So taking an example, I defined a set with three elements. So you can see the differences I'm defining these elements within these curly braces. Then I add a particular element to that set and I get the result of these four elements. Then I update it with a, see guys, during updation, we can also provide a list as well. And the result would simply be an aggregated set with those elements from this list added, right? Let me execute this cell so that we can see the results as well simultaneously. So once I update 5 and 6, this is the result that I get. 1, 2, 3, 4, 5, 6. I've added all these comments, guys, and you can also check in the resources section of this video. And if I update with a couple of sets, then all the elements corresponding from these sets get added to the source set, that is my set. If I remove 3, then it will find 3, and in case it doesn't find that element, it will raise an error. We'll also be having a look at how to handle errors and exceptions. If I attempt to pop, it'll return a random item and the set will be containing the remaining elements. Right, guys? And in the talking with respect to looking at the set difference, we can see that this method is defined as my set or the source set differenced with another set. And this will return items that are present in my set or in the source set, but are not present in set 2, right? So if I take the difference between this set 1, 2, 3, 4, 5, 6, 7, 8, 9 and 5, 6, 10, then 5 and 6 will be skipped, right? So I can see that after popping, I got this result and 5 and 6 were skipped. If I attempt to take an intersection of these two sets, I will get the common elements that are present in both the sets. That is 5 and 6. If we perform union of the two sets, then we will get the combined set. That is, we will get the element 10 as well in the source set. And these changes are not being made to my set itself, but rather this result will need to be assigned to another container in order to get the result. Then symmetric difference will return items that are only in one set but are not in both, right? And is superset we can check that is this small set 5 comma 6, is this a superset of my underscore set elements? And this returns true because 5 and 6 are contained within my set. You can see 5 and 6 are contained. This is the result of symmetric difference. So symmetric difference will return elements that are unique to each set. If I try to find is subset, that whether all of these elements are, if I try to find is subset, that is my set, my underscore set contained within the set that I'm providing within the argument, then it'll return true or false. That is, all these elements 2, 4, 7, 8, 9, and 10 are indeed contained within the set that I have provided, and it is a subset of this provided set, right? So, guys, experiment with a bunch of random elements, a bunch of sequential elements, and try to get a hands-on understanding of how sets work, as it is quite useful in particular niche situations. So see you in the next video, guys.